Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the four lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets. So that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that would be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the two parallel sides here, which just pick a different colour, here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14. Therefore the radius would be half of that, which is 7. And the area of the circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now I'll keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium is 294, the circle is 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6991000. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chelton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chelton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chelton at 9 o'clock. He drives from Chelton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time. And we're covering up the time, because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of two numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers, just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares. And we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them, so I cross them both out and put 2 in the middle. We can see they both have a 3 in them, so cross those 3's out and put 3 in the middle. And then 450 has a 3, a 5 and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. There are two rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now, this red line does not go through the origin, so A and B cannot be in direct proportion. I'm just going to write the question out a bit bigger, just so we've got more room. And loads of different methods of expanding brackets. I'm going to do smiles and rainbows. So we just draw a smile rainbow, and I put a little line there to remind me to times it. So we do 5 times 7, which is 35, and it's 7x, so it's going to be 35x, and 5 times 4, which is 20. So the answer is 35x plus 20. So I'm going to write the equation out, the formula out. And we're asked to make y the subject, so I'm just going to get my lines in. And so what's stopping us from having y on its own? Well, this minus 1. How am I going to get rid of it? Add 1 both sides. So we've got x plus 1 equals 9y. What else do we have that stops y from being on its own? Well, there's times 9 here. So we're going to do the opposite, the inverse, which is divide by 9 both sides. And to do that nicely, what we do is we just do it as a fraction. X plus 1 over 9 equals y. So therefore y is x plus 1 over 9. We can write the equations of all linear graphs as y equals mx plus c, with m being the gradient and c being the y-intercept. The easiest thing to find is the y-intercept, because it's just where the line crosses the y-axis, so that's going to be minus 2. We're going to use that point, so the point we've just drawn on, and we're going to have to find another point to find the gradient. Now, I don't really like this point because I don't really know where that is, and we've got to find a coordinate we know the coordinates for. So looking at this, this is a nice coordinate here. And what I'm going to do is just draw a right angle triangle between the 2 points. Try and get it as nice as I can. And we're going to work out how far up and how far right we went. Well, we went 3 right and 4 up. Now, to find the gradient, what we want to do is we find out how much y has changed, so change in y, so that's how far up it's gone, which is 4, and put that over how far right it's gone, so the change in x, which is going to be 3. So our equation is going to be y equals 4 over 3 x minus 2. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. When you have a fraction, it's just a fancy way of showing a divide. So this is x to the power of 11 divided by x to the power of 3. And indices rules say that when you divide two powers with the same base, you subtract the powers. So it becomes 11 take away 3. 11 take away 3 is 8. So that's x to the power of 8. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center x, and we can say that there are 19 take away x just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus x. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus x, the 15 minus x, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus x and minus x, so that will be a minus x. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know x is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here, because all of these are congruent parallelograms, and we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down 2 lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2Q. There are two shapes we need to find the volume of. There's this cylinder here and this hemisphere here. So we might as well start with this cylinder. And the formula for the volume is pi times r squared times height. So it's the radius is 9, so 9 squared times the height, which is 30. And when we work that out, we get 7,634.070, blah, blah, blah. Next is the hemisphere. To find the volume of the hemisphere, well, the volume of a sphere is 4/3 times pi times r cubed. but because it's a hemisphere, we just times that by a half. So it's half times 4/3 times pi times r, which is the radius, which is 9 cubed. And that gives us 1526.814 blah blah blah. And so the total volume is 7634.070 blah 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 plus the 1526.814 blah blah blah, which equals 9160.884 blah blah blah. It says it wants it to 2 decimal places, so when we round that we get 9160.88. This question, we're adding fractions. Okay, there's a bit of algebra, but the process is exactly the same as when we've always added fractions. We need to find out what the lowest common multiple of 4 and 7 is. Well, actually, the lowest common multiple is 28, which is 4 times 7. So what we're going to do is multiply the left-hand fraction by 7. So we're going to times the k by 7, which will give us 7k. And we're going to times the 4 by 7, which will give us 28. And we're going to times the right-hand fraction by 4, which will give us 4k at the top. And it will also give us 28 as the denominator. Now, when the denominators are the same, we just add the numerators. And 4k plus 7k, or 7k plus 4k, will be 11k. And the denominator will be 28. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. I'm going to start by identifying the equations of each line. So here we've got y equals 2, because the y coordinate is always 2 on this line. This one here we've got x equals minus 3, because the x coordinate is always minus 3. And this next one is a bit more difficult, but it's perfectly diagonal, so it's going to be a y equals x line. But if you look, it crosses the y-axis at minus 1, so it's going to be y equals x minus 1. Okay, these are not inequalities though, so we need to work out what the inequalities are. So we're looking at the region, which is here, and we can pick a point in the region. I normally try and pick a nice easy one, so let's pick 0, 4. So 0, 4 is in our region. So 0, 4, let's compare that to our y equals 2. Well, what is that compared to 2? Well, it's actually greater than 2. So it's y is greater than 2. We have a look, the fact that our line is dashed, it's not going to be equal to 2, because it's saying it's not on that line. Okay, this next one, let's have a look at this. Well, is it greater? Is that 0 greater than minus 3? Well, yes, it is. So it's going to be x is greater than minus 3. Again, the line is dashed, so it can't be on the line. Now, this last one's a bit more difficult, because it's got x and y in it. So we feed in the values. So for our coordinate that we've picked, x is 0 and y is 4. So 4, and I'm just going to put, I don't know, not equal to, but or I'm just going to leave that blank, leave that as a box. And 0 minus 1. So all I've done is fed in the coordinate values into this equation. And I've got rid of the equals, because what we need to do is work out what inequality it's going to be. 0 take away 1 is minus 0. So what is 4 compared to minus 1? Well, 4 is definitely greater than minus 1. So it's going to be y is greater than x minus 1. But if you look, this line is solid. It's a solid line. It's not a dashed line. Therefore, we're going to put a little line underneath it, because it can equal it as well. In this question, it might be easier just to draw a quick diagram. So let's draw this equilateral triangle, and it says that its lengths are all 10 centimeters. and we're looking to find the area. Now we also know with an equilateral triangle all the angles are 60 degrees, so we can plot those, but we don't need to plot them all, we can just plot one of them. And we know that to find the area of a triangle, we can use this formula here, which is half AB sine capital C. And if we have a look at this diagram, we can label the sides. So I'll call this side, this angle C, and little c here, and little a here, and little b here. So let's put that into our formula. Little a is 10, little b is 10, and sine c, which is 60. So with a, b and c, it doesn't matter what you label a, b and c, as long as the angle is opposite the side with the same letter. The angles are all capital letters, the lengths are all lowercase. Okay, so let's put that into our calculator and we get the answer of 43.301, blah blah blah. It says it wants it to 2 decimal places, so that is 43.3. I'm going to start by labelling this triangle, and so I'm going to pick a lowercase a here, uppercase A I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the C's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345, blah blah blah. So we're going to solve this. It's going to be a nice and easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah blah blah. And when we round that, we get 2.68. We're going to start by creating a table of frequencies from this histogram. And so we are going to need our times first of all, then our frequencies, and then we can add a midpoint and an FX column as well, which we'll need for later. So our times, then our frequencies, then our midpoints, then we'll do the FX later on. Right, so the first group is 0 to 10. And to find the frequency, well, I might as well just show this. So the frequency density is proportional to the frequency over class width. The class width here is 10, and the frequency density is 1.2, so 10 times 1.2 will be 12. And then the next group is up to 30, so we're doing 20 times 3.2, which will be 64. And then the final one will be 30 to 50. So again, we're doing 20 times 0.8, which will be 16. Okay, so we've got our table from the histogram, and we're asked to find the mean. So hence us doing the midpoint, etc. So the midpoint is 5, 20, and 40. And then the FX, we just times these together, and that would be 60, 1,280, and 640. Now, something I said earlier is that the frequency density is proportional to the frequency divided by class width. It does tell us there are 92 people, and if you do the sum of the frequencies, you do get 92. So we know that it's a one-to-one relationship. Okay, so let's do the sum of the fx by adding up these numbers here, and you get 1980. So to find the mean, we do the sum of fx over the frequency, sum of the frequencies, and that will give us 21.521, blah blah blah, and 2 decimal places, which is what the question asks for, it's 21.52. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.